Now let's see exercise second problem. First bit, find the zeros of the quadratic polynomials and verify the relationship between the zeros and coefficients. So first, what is the first one? X square. Let us think this is p of x. P of x is equals to x square minus 2x minus 8. So we have to find the zeros and verify the relationship between zeros and coefficients. Here, if you compare, let us compare it with the general quadratic polynomial. What is the general quadratic polynomial? Ax square plus bx plus c. If we compare with the general quadratic polynomial, coefficient of x square a is equals to here 1, right? So a is equals to 1, and b, coefficient of x, b is minus 2, and constant term c is minus 8. Now let's find the zeros. P of x is equals to x square minus 2x minus 8. We have to take p of x value 0 as we are finding the zeros. So 0 is equals to, here we have to multiply the coefficient of x square 1 and constant term minus 8. One into minus 8 is equals to minus 8. And what are the suitable factors? The factors of minus 8 must be such that if we multiply we should get minus 8, and if we add we should get middle term minus 2. So upon multiplication we should get minus 8, upon addition we should get middle term minus 2. So what are the suitable factors? Minus 4 into 2 is equals to minus 8. Upon multiplication we got minus 8, and upon addition minus 4 plus 2 is equals to minus 2. So therefore the suitable factors are minus 4 and plus 2. So x square, let's rewrite minus 2x as minus 4x plus 2x minus 8. 0 is equals to, from the first two terms let's take x common. If you take x common from the first term we will have x. If you take x common from the second term we will have minus 4. Now let's take 2 from the third term and fourth term. 2 common. If you take 2 common from the third term we will have x. 2 common from the fourth term we will have minus 4. So again let's take x minus 4 common from the first two terms. So 0 is equals to x minus 4 of, if you take x minus 4 common from the first term we will have x, and if we take x minus 4 common from the second term we will have plus 2. So 0 is equals to x minus 4 into x plus 2. So we will take here x minus 4 equal to 0 or x plus 2 equals to 0. So here x is equals to 4. If you send minus 4 to the right side and send plus to the right side, we will get x is equals to minus 2. Let alpha is the first 0. Let us take alpha is equals to first 0 4 and beta is equals to second 0 minus 2. Now what is the first relationship? Sum of the zeros alpha plus beta must be equals to minus b by a. Let's check. Alpha plus beta. Alpha plus beta is equals to, alpha is plus 4 plus beta is minus 2. Plus 4 minus 2 is plus 2. And what is minus b by a? Let's check it. Minus b by a minus, what is the b value? Here b value is minus 2. B value is minus 2 and a value is 1. Minus 2 by 1. minus of minus 2 by 1. So b value is minus 2 and a value is 1. So minus of minus 2 is plus 2. So plus 2 by 1 is equals to plus 2. So therefore we got sum of the zeros is plus 2, minus b by a is also plus 2. So therefore sum of the zeros alpha plus beta is equals to minus b by a. So next, second relationship, product of zeros alpha into beta. So alpha is plus 4, beta is minus 2. Plus 4 into minus 2 is minus 8. Now c by a, we should get alpha into beta is equals to c by a. So c by a, what is the c value? C value is minus 8 and a value is 1. So minus 8 by 1. Minus 8 by 1. Minus 8 by 1 is minus 8. So product of this is minus 8. C by a is also minus 8. So therefore we get alpha into beta is equals to C by a. The second relationship has been verified. Hence verified the two relationships. So what is the second question? 4s square minus 4s plus 1. So we have to find its zeros and verify the relationship between the zeros. So let's write what is given. Here the variable is s. So p of s is equals to 4s square minus 4s plus 1. Let's compare with the general quadratic polynomial. So what is the general quadratic polynomial? Let's take variable s, as square plus bs plus c. So if you take coefficient of s square, a is equals to 4 here. So a is equals to 4 and coefficient of sb is equals to minus 4 and constant term c is equals to 1. So let's take p of s is equals to 4s square minus 4s plus 1. So let's take p of s value is 0. So 0 is equals to 4s square minus 4s plus 1. We have to multiply the coefficient of s square 1 into constant term 1. So coefficient of s square is 4, right? So 4 into constant term 1, 4 into 1, 4. Now the product of the factors of 4 must be such that if we multiply we should get plus 4 and if we add we should get middle term minus 4. So the suitable factors are minus 2 into minus 2 is equals to plus 4 and upon addition minus 2 plus minus 2 is equals to minus 4. So upon multiplication we got plus 4, upon addition we got minus 4. The suitable factors are minus 2 and minus 2. So let's rewrite the middle term. 0 is equals to 4s square minus 4s can be written as minus 2s minus 2s plus 1. From the first two terms let's take 2s common. If you take 2s common from the first term we will have one more s. If you take 2s common from the second term we will have only minus 1. Now Let's take minus 1 common from the third term and fourth term. If you take minus 1 common from the third term, we will have 2s. If you take minus 1 common from the fourth term, we will have minus 1. Second, take s minus 1 common. So here we will have 2s, sorry. So let's take 2s common. So let's take 2s minus 1 common. So if you take 2s minus 1 common, we will have 2s here and minus 1 here. So let's make these equal to 0. So 2s minus 1 equals to 0, or 2s minus 1 equal to 0. So here let's send minus 1 to the right side. 2s is equals to 1, and send 2 to the right side. S is equals to 1 by 2. The same number we will get here. 2s is equals to 1 and s is equals to 1 by 2. So let first 0 alpha is 1 by 2, second 0 beta is 1 by 2. Here we got two equal zeros. Let's verify the first relationship, sum of the zeros. Sum of the zeros must be equals to alpha plus beta must be equals to minus b by a. So alpha plus beta. What is alpha plus beta? Alpha is 1 by 2, beta is also 1 by 2. 1 by 2 plus 1 by 2. 1 plus 2 by 2, sorry. 1 plus 1 by 2. So alpha plus beta is equals to 2 by 2, which will be equals to 1. Next, minus b by a value. So minus b is minus 4, right? So minus of minus 4 by a is also plus 4. Minus of minus 4 is plus 4 by 4, which is equals to 1. So here sum of the zeros is plus 1. Product of zeros is also plus 1. So therefore we can write it as alpha plus beta is equals to minus b by a. Next, product of zeros, alpha into beta must be equals to c by a. So alpha into beta. What is alpha? Alpha is 1 by 2. Beta is also 1 by 2. 1 by 2 into 1 by 2 is equals to 1 by 4. Next, c by a. So c is 1. Already we got c is 1, right? Yes, here. C is 1 and a is 4. So 1 by 4. So alpha into beta is 1 by 4. C by is also 1 by 4. So therefore we will get alpha into beta is equals to c by a. Hence verified. So the third question is 6x square minus 3 minus 7x. So we have to find the zeros of this polynomial and find the relationship between, verify the relationship between the zeros and coefficients. Let's write what is given. Let p of x 6x square minus 3 minus 7x. Let's write this in standard form. P of x is equals to 6x square minus 7x minus 3. Let's compare with a general quadratic polynomial, ax square plus bx plus c. So if you compare with a general quadratic polynomial, the quotient of x square, a is equals to 6. So we will get a is equals to 6. And b, coefficient of x, which will be equals to minus 7 here. And constant term c is equals to minus 3. So let's find the zeros of the given polynomial. P of x is equals to 6x square minus 7x minus 3. To find the zeros of this polynomial, we have to take P of x value 0. So 0 is equals to 6x square minus 7x minus 3. So we have to multiply the coefficient of x square 6 and constant term minus 3. 6 into minus 3 is minus 18. The factors of 18 must be such that if we multiply we should get minus 18, and if we add we should get minus 7. So what are the suitable factors? Minus 9 into plus 2 is equals to minus 18. Upon multiplication we are getting minus 18. Upon addition, minus 9 plus 2 will be equals to minus 7. So 0 is equals to 6x square. This minus 7x can be written as minus 9x plus 2x minus 3. So from the first two terms, let's take 3x common. So 3x common. If we take 3x common from the first term, we will have 2x. And if we take 3x common from the second term, we will have just 3. That's it. And just from the third term and fourth term, just nothing is common, only plus 1. So take plus 1 common. So it will be equals to plus 1 of 2x minus 3. 0 is equals to, now again take 2x minus 3 common. If we take 2x minus 3 common here, so here we will have 3x and plus 1. 3x plus 1. So we have to make these two factors equal to 0. 2x minus 3 equal to 0, or 3x plus 1 equal to 0. Send minus 3 to the right side. We will get 2x is equals to 3. Send 2 to the right side. Now x is equals to 3 by 2. So the first 0 is 3 by 2. And here send minus 1 to the right side. 3x is equals to minus 1. 3 to the right side. X is equals to minus 1 by 3. So this is the second 0. Let the first 0 be alpha. First 0 will be alpha 3 by 2. And second 0 beta will be equals to minus 1 by 3, right? Now first relation, sum of the zeros, alpha plus beta. What is alpha plus beta value? 3 by 2 plus minus 1 by 3. So what is the LCM of denominators? LCM of 2 and 3 is 6, right? So let's make the denominators equal. 3 by 2 multiply with 3 by 3 to make the denominators equal, minus 1 by 3 multiply with 2 by 2 to make the denominators equal. Now 3 into 3 is 9, 9 by 6 minus 1 into 2, 2 by 6. Now denominators are equal, add the numerator, 9 minus 2 by 6. So alpha plus beta is equals to 7 by 6. Next, minus b by a. So what is the value of minus b by a? Minus b by a minus, what is b and what is a? Let's see here. Yes, here b is minus 7, a is 6. So minus 7 by 6. Minus 7 by 6. So b is minus 7 and a is 6. So minus b by a is equals to minus of minus 7 plus 7 by 6. So what we got? Alpha plus beta is 7 by 6, minus b by a is also is equals to 7 by 6. So therefore we can write alpha plus beta is equals to minus b by a. The first relationship has been verified. Then the second relation. What is the second relation? Product of zeros. Alpha into beta. So here alpha is 3 by 2 into beta is minus 1 by 3. So that will be equals to 3 into minus 1 minus 3 by 2 into 3, 6, minus 3 by 6. Next, c by a value. So what is the c? Let's see c. So this is c. So c is equals to minus 3. So c by a means minus 3 by a value is 6. So minus 3 by 6. So product of zeros is minus 3 by 6 and c by a is minus 3 by 6. Therefore we can write alpha into beta is equals to c by a. So the second relationship has been verified. Next, fourth question is 4u square plus 8u. 4u square plus 8u. So we have to find the zeros of this quadratic polynomial and verify the relationship between the zeros. So here the variable is u, right? Let us take p of u is equals to 4u square plus 8u. Let's compare with the general quadratic polynomial. What is that? A u square, if we take the variable, plus bu plus c. So if you compare with the general quadratic polynomial, so we will get the coefficient of u square a. So a is equals to 4. The coefficient of u b, which is equals to 8 here. The constant term c is 0. Constant term is not there here. So a value 4, b value 8, c value 0. Now let's find the zeros first. So what is given? P of u is equals to 4u square plus 8u. So to find its zeros, we have to make it equal to 0. So for that we have to take p of x value 0. So p of u value 0. So 0 is equals to 4u square plus 8u. 0 is equals to, let's take 4 common, 4x common, 4u common, sorry. From the first term and second term you can take 4u common. 4u is equals to, if you take u common from the first term, so 4u common from the first term, we will have one more u, and if you take 4u common from the second term, we will have 2. So here 4u into u plus 2 is equals to 0. That means here 4u is equals to 0 or u plus 2 is equals to 0. Send 4 to the right side, you will get u is equals to 0 by 4. Otherwise you will get u is equals to 0. Next, send plus 2 to the right side, u is equals to minus 2. So first 0 is 0 and second 0 is minus 2. Let alpha is equals to 0, first 0, and beta is equals to minus 2. Now we have to verify the relationship between these zeros. So what is the first relation? Sum of the zeros. So we should get alpha plus beta should equals to minus b by a. So let's add alpha plus beta. Alpha plus beta is equals to, alpha is 0 plus beta is minus 2, which will be equals to minus 2. Now b by a, minus b by a, minus, so what is the b value? B value is 8, right? So b value is 8 and a value is 4. Next, fifth question is t square minus 15. T square minus 15. Here the variable is t. Let's write. Let's take p of t is equals to t square minus 15. So let's compare it with the general quadratic polynomial with variable t. A t square b t plus c. So if we compare with the general quadratic polynomial, coefficient of t square here 1. So a will be equals to 1. Coefficient of t b is equals to 0. So there is no t term in the given polynomial, right? So c constant term is here minus 15. Now let's find the zeros. To find the zeros, we have to take p of t value is equals to 0, right? T square minus 15. Now let's take p of t value is 0. So 0 is equals to t square minus 15. Otherwise we can write it as t square minus 15 equal to 0. Send minus 15 to the right side. We will get t square is equals to 15. Now t value will be equals to, so t will be equals to plus or minus root 15, because plus root 15 whole square is plus 15, minus root 15 whole square is also plus 15. So that is how t is equals to plus or minus root 15. So let the first 0 alpha b is equals to plus root 15, and second 0 beta is equals to minus root 15. Now first relation, sum of the zeros, alpha plus beta we should get equals to minus b by a. Let's do it. So alpha plus beta, alpha plus beta. So here alpha is plus root 15 and beta is minus root 15. So those will be equals to 0. Plus root 15 minus root 15 is equals to 0. And minus b by a value. So here minus, what is the b value? B value and a value. B is 0, a value is 1. So b is 0, a value 1. So minus 0 by 1 is 0. So sum of the zeros is 0 and minus b by is also equals to 0. So therefore we can say that alpha plus beta is equals to minus b by a. So the first relationship has been verified, and let's see the second relation. So what is the second relation? Product of zeros, alpha into beta should equals to c by a. So alpha into beta, alpha is plus root 15 and beta is minus root 15. Plus root 15 into minus root 15 is, here we will have plus, right? Plus into minus is minus, root 15 into root 15 plus 15. Now let's see c by a. So we know that c is minus 15 and a is 1. Minus 15 by 1 is minus 15. So therefore we can say that alpha into beta is equals to c by a. Product of zeros is equals to c by a. So this is also verified. Hence verified. Next, the sixth problem, 3x square minus x minus 4. So we have to find its zeros and verify the relationship between the zeros. So what is that? Here the variable is x, right? P of x. P of x is equals to 3x square minus x minus 4. So if you compare with the general quadratic polynomial, ax square plus bx plus c. So if you compare with the general quadratic polynomial, coefficient of x square, a is equals to 3, coefficient of b is equals to here minus 1. So b should be is equals to minus 1, and constant term c is equals to minus 4. Now to find its zeros, we have to make it equal to 0. So p of x is equals to 3x square minus x minus 4. Take p of x value 0. So 0 is equals to 3x square minus x minus 4. So to factorize it, we have to multiply the coefficient of x square 3 and constant term minus 4. So 3 into minus 4 is minus 12. So the factors of 12 must be such that if we multiply we should get minus 12, and if we add we should get the middle term minus 1. So upon multiplication we should get minus 12, upon addition we should get the middle term. So here this is minus 1, right? So minus 1 we should get. So the suitable factors are the same, I think. Minus 4 into plus 3 is equals to minus 12, and minus 4 plus 3 is equals to minus 1. So these are the suitable factors. So 0 is equals to 3x square. The middle term minus x can be written as plus 3x minus 4x, and constant term minus 4 as it is. So now take 3x common from the first two terms. So if you take 3x common from the first term, we will have x. If you take 3x common from the second term, we will have plus 1. And from the third term and fourth term, let's take minus 4 common. If you take minus 4 common from the third term, we will have plus x. And minus 4 common from the fourth term, we will have plus 1. Again take x plus 1 common. So we will get, this is equals to x plus 1 of, if you take x plus 1 common from the first term, we will have 3x. If you take 3x plus 1 common from the second term, we will have minus 4. So here x plus 1 of 3x minus 4 equal to 0. So we have to make these two equal to 0. So x plus 1 is equals to 0 or 3x minus 4 equal to 0. Send plus 1 to the right side. Now x is equals to minus 1 and minus 4 to the right side. 3x is equals to 4 and x is equals to, if you send 3 to the right side, you will get 4 by 3. So here the first 0 is minus 1, second 0 is 4 by 3. So let alpha is equals to minus 1 and beta is equals to 4 by 3. Let's verify the first relation. What is the first relation? Sum of the zeros should be equals to minus b by a. Right. What is the sum of zeros first? Alpha plus beta is equals to minus 1 plus 4 by 3. Minus 1 plus 4 by 3. This minus 1 can be written as minus 1 by 1. To make the denominators equal, multiply this with 3 by 3 plus 4 by 3. So minus 1 into 3 minus 3 by 3 plus 4 by 3. So now denominators are equal. We can add the numerators directly. Minus 3 plus 4 by 3. So now sum of the zeros is equals to minus 3 plus 1 plus 4 plus 1 by 3. So sum of the zeros is plus 1 by 3. Now minus b by a value. So what will be the minus b by a value? Minus b by a minus, what is the b value? So b is minus 1, a is 3, c is minus 4. So b is minus 1, a is 3. So minus of minus 1 is plus 1 by 3. So minus b by a value is 1 by 3. Sum of the zeros we got 1 by 3 and minus b by is also 1 by 3. So therefore we can say that alpha plus beta is equals to minus b by a. The first relationship has been verified, and let's see the second relation. So what is the second relation? Product of zeros. Alpha into beta should equals to c by a. Let's check. Alpha into beta. Here alpha is minus 1, beta is 4 by 3. So minus 1 into 4, minus 4 by 3. So product of zeros is minus 4 by 3. Now let's see c by a. So we know that c is minus 4 and a is 3. So minus 4 by 3. So we got the same values. Alpha into beta is minus 4 by 3. C by is also minus 4 by 3. Therefore we can say that alpha into beta is equals to c by a. The second relationship has been verified. Hence verified. Next, second bit. Find the quadratic polynomial. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros. respectively. So the first one is sum of the zeros and second one is product of zeros. So let's take the first one. What is the first one? So let the sum of the zeros. Sum of the zeros. If alpha and beta are the zeros of the polynomial, so we have to take, let sum of the zeros is given as 1 by 4 and product of zeros alpha into beta is given as -1. So if you think alpha is the first zero and beta is the second zero, sum of the zeros is 1 by 4 and product of zeros is -1. So we have to find the polynomial with these two things. So what is the formula? So we know that if you take x is the variable, then the polynomial will be equals to p of x is equals to k of, where is k is some constant, x square minus x of sum of the zeros alpha plus beta plus product of zeros alpha into beta. So now let's substitute the values. K of x square minus x of alpha plus beta means 1 by 4. Next alpha into beta is -1. So alpha plus beta is plus 1 by 4. Alpha into beta is -1. Now k of, so here denominator is 4, right? So first of all let's write x square can be written as x square by 1 minus x into 1 minus x by 4, and this 1 can be written as 1 by 1. So the LCM of denominators is 4. Let's make all the denominators 4. For that we have to multiply this x square by 1 with 4 by 4 and x by 4 as it is, and this -1 by 1 with 4 by 4 to make all the denominators equal. Now this will become k of x square into 4, 4x square by 4 minus x by 4 minus 1 into 4 minus 4 by 4. So now all denominators are equal, so k of, we can write 4x square minus x minus 4 by 4. Here denominator is 4. So if k value is 4, if k value is 4, this will be cancelled. So for example here, if k value is 4, so this k value 4 and this 4 will be cancelled. So therefore after cancellation we will get what? We will get p of x is equals to 4x square minus x minus 4 if, only if k is 4. When k is 4, this k and the denominator 4 will get cancelled. So the required quadratic polynomial is this one. Next, second question is sum of the zeros is √2 and product of zeros is 1 by 2. So let's write here second one. Let alpha and beta are the zeros. So alpha plus beta is equals to 1 √2 and product of zeros alpha into beta is equals to 1 by 3. So now we have to find the polynomial with these two things. So what is the formula to find the polynomial? P of x is equals to k of x square minus x of alpha plus beta plus alpha into beta. So k of x square minus x of alpha plus beta. So here alpha plus beta is √2 plus alpha into beta is 1 by 3. So k of, so this x square can be written as x square by 1 minus x into root 2. So minus root 2x can be written as by 1 plus 1 by 3. Here the LCM of denominators is plus 3. So let's make all denominators equal. K of, so x square by 1, to make denominators equal multiply with 3 by 3. Next minus root 2x by 1 multiply with 3 by 3 plus 1 by 3 as it is. It has already denominator 3, right? So now this will be equals to k of x square into 3, 3x square by 3 minus root 2x into 3 minus 3 root 2x, 3 root 2x by 3 plus 1 by 3. Now denominators are equal. Add the numerators directly. K of, we can write it as 3x square minus 3 root 2x plus 1 whole by 3. Here the denominator is 3, right? If k value is 3, this k and denominator 3 will get cancelled. So now the polynomial will be equals to p of x will be equals to 3x square minus 3 root 2x plus 1 if k value is 3. So the required polynomial is this one. Next, third problem is sum of the zeros is 0 and product of zeros is root 5. So let's write, if alpha and beta are the zeros of the polynomial, so sum of the zeros alpha plus beta is 0 and product of zeros beta is equals to root 5. So what is the formula? P of x is equals to k of x square minus x of alpha plus beta plus alpha into beta. Let's substitute the values. K of x square minus x of, what is alpha plus beta is 0. So next product of zeros alpha into beta is yes, alpha into beta is root 5. So k of x square minus x into 0, 0. So total it will become 0. So we will have plus root 5. Here we don't have any denominator, right? So if there is no denominator, so it will be equals to 1, right? Now if k value is 1, now the polynomial will be equals to p of x, it will be equals to x square plus root 5 if k value is 1. So the required polynomial is this one. Next, the fourth problem is sum of zeros is 1 and product of zeros is 1. Let's write it. If alpha and beta are the zeros, sum of the zeros is 1 and product of zeros is also 1. Now what is the formula? P of x is equals to k of x square minus x of alpha plus beta plus alpha into beta. So k of x square minus x of alpha plus beta is 1, right? Plus alpha into beta is also 1. So now k of x square minus x into 1 minus x plus 1. Here we don't have any denominator, right? So now if k value is 1, then we will get P of x is equals to x square minus x plus 1 if k value is 1. So the required polynomial is this one. Next, the fifth problem is sum of the zeros is minus 1 by 4, product of zeros is 1 by 4. Let's write if alpha and beta are the zeros, sum of the zeros is equals to minus 1 by 4 and product of zeros alpha into beta is equals to plus 1 by 4. So what is the formula? P of x is equals to k of x square minus x of alpha plus beta plus alpha into beta. Now k of x square minus x of alpha plus beta is equals to minus 1 by 4, right? Alpha into beta is equals to plus 1 by 4. Now k of x square can be written as x square by 1. It has no denominator. Next, minus x into minus 1 is equals to plus x by 4 plus 1 by 4. Now multiply k of x square by 1, multiply this one with 4 by 4 to make all denominators equal, plus x by 4 as it is plus 1 by 4 as it is. Now this will be equals to k of x square into 4, so 4x square by 4 plus x by 4 plus 1 by 4. Now all denominators are equal, right? Add the numerators directly. So 4x square plus x plus 1 whole by 4. Now if if k is 4, here denominator is 4, right? If k is 4, k and 4 gets cancelled. Now we will have p of x is equals to, we will get 4x square plus x plus 1 if k value is 4. So the required polynomial is this one. The next problem is the last problem of this chapter and this exercise. So sum of the zeros is 4 and product of zeros is 1. So if alpha and beta are the zeros of the polynomial, sum of the zeros alpha plus beta is 4, product of zeros alpha into beta is 1. So what is the formula? P of x is equals to k of x square minus x of alpha plus beta plus alpha into beta. Now k of x square minus x of alpha plus beta is given as plus 4, right? Plus alpha into beta, product of zeros is given as 1. So now this will be equals to k of x square minus x into 4 minus 4x plus 1. Here we don't have any denominator, right? So if k value is 1, then p of x will be equals to x square minus 4x plus 1 if k is equals to 4. So the required polynomial is this one.